in this example, we have some meaning behind the function, and we are asked to find so F is the amount of time spent foraging for food of a particular bird, and E is the amount of energy that they actually expend doing that. And it depends on the amount of time, the value of F following this model. And we want to minimize, find the foraging time, find the F value, in other words, the X value of our other types to minimize E. This example, we're not given a domain specifically, like our previous example. But since F is amount of time spent, we know that F has to be bigger than 0. I guess technically it could be equal 0 in general, but not with this model, because then you'd be dividing by 0. And then per day in hours, I guess F the maximum it would be 24. But let's look at this in general without any consideration of the domains. And whenever you're asked to maximize or minimize something, we need to find the derivative. And in order to do this, it might be easier to rewrite this. And then find the derivative. I'll do it fairly quickly, 0.25. And then we'd have minus 2 times 1.7, which I'll write it as minus 3.4, F to the negative 3. And I'm going to rewrite this back in fraction form, so we can see how we might look at what the critical points are. And in this case, we want to get this under a common denominator. So I would multiply this term, top and bottom, by F cubed. So I'll go ahead and write it that way. And then I have 0.25 F cubed minus 3.4 all over F cubed. And we want the critical numbers. We have F equaling 0, technically is undefined, but that wasn't in our domain to begin with. And then we have a critical number when 0.25 F cubed minus 3.4 equals 0. So we do algebra, figure out we're looking at F cubed to equal 3.4 over 0.25. F would be the cube root of this number. And I'll just write it this way for now. And I guess it's about 2.387. So remember, that would be about a little over 2 hours. Now, that's a critical point. We want to know, is this going to give us a minimize energy? One way is to look at the graph, try to figure out, is this a minimum? Did we go from decreasing to increasing? Another way that might be quicker for this particular problem is to use the second derivative test. If we look at the second derivative, this term goes away. The negatives, we end up with positive 3.4 times 3 F to the negative 4, or 3.4 times 3 over F to the 4th. So what does that tell us? That tells us that the second derivative is always positive. So the function is always concave up. So this tells us this is a minimum. So what were the directions? We wanted to find the time, amount of time. So they were asking for what is the input value, in this case F, in this case in the hours per day. We didn't care what that actual energy was. We just wanted to know what is the amount of time.